You can set it over here. It's gonna beep. Oh, that's fine.
I can beep 30 seconds before it. In a less annoying
You can
way.
beep before.
Yeah, in a less annoying way. So
Okay.
You know the annoying ones.
Got it. Perfect. Okay. Welcome, 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 everyone. It is nice to see each and every one of you today. It is Pi Day. It is also St. Patrick's Parade. It is also a great day to touch grass. So we're going to go through the speaker series. People are welcome to stay to hack here inside, hack outside, touch grass outside. And I hope you guys all enjoy these wonderful days here at EduNode in Presidio. This is as intimate as it is, just one of the few events that we're hosting here over the next few weeks. So we'll welcome everybody and all of your friends again for amazing events like poker night and ice cream trucks and whatnot. So I hope you guys take a chance to take a few minutes and come over and enjoy those events with us. My name is Oleg. I am the product lead at Sentient Labs. We're an open source AI product and research lab focused on two things. We want to advance the frontiers of AI reasoning through, one, automating the AI engineering process, and also focusing on AI co-development. We think that true solutions in AI are going to be born out of collaboration and healthy, but not too crazy competition. And so we, as Sentient, have hosted dozens of events all over the world since 2024 in Korea, India, China, France, Dubai, Argentina, and more. And we're now moving our efforts closer to the heart of the Silicon Valley here in San Francisco. So I welcome you here today, and thank you for welcoming us here in the city. Thank you, thank you. So today's Pi Day, as I said. It is also the launch of Sentient Arena. It is a competition platform where we define the most challenging reasoning problems in AI today and have participants compete on solving them. Our first group of participants, many of whom are online and watching the live stream right now, Cohort 0, have been selected out of more than 1,000 applicants. And if you are here and not part of Cohort 0, we welcome you to stay and hang out with us nonetheless. There are many other arenas out there. Arena is a kind of overused term now in AI because everybody's trying to build the ultimate competition. What we noticed is that every time the teams submit their solutions for scoring, nobody actually learns anything out of that process. In fact, I would say that even the solution itself does not matter as much as the process that got you to that solution. It is what worked, what didn't work, why it didn't work, and how you built your AI solutions, maybe even leveraging AI itself through the use of what we call evolutionary or self-improvement algorithms. That is actually what matters. And so at Sentient Arena, I want to differentiate that We want to enable this exploration in the open with the goal that your solutions can be part of the open source AI story. For the same reason, for those who stay after the talks to hack or simply to network, I want to share with I want to share with all of you my personal belief is that you need to be able to share your prototypes, your ideas, bounce off of each other, brainstorm together, and thus it might be an opportunity for you not just to build, but also to conduct meaningful research and possibly actually find long-term collaborators. So the talks today will be focused on two things. They'll be focused on grounded reasoning and AI evolution and AI self-improvement. We'll hear from wonderful speakers across multiple amazing startups that will hopefully teach you something if you're participating in the hacking on how to help you succeed in the challenge, and otherwise maybe help you succeed in your own startups or simply give you some ideas to try. Outside of this event, as I mentioned, Sentient has prepared and organized an entire 3 weeks of events and co-working here at Edge and Node in Presidio. This week, on Wednesday, we'll have an ice cream truck. And then next Saturday, we will have a poker tournament. So share the invites with your friends and sign up ASAP. Slots are limited, with obviously Cohort 0 being getting the priority. And in other words, welcome to the club. So let's talk about Challenge Zero for a second, which is the kind of the basis of the hybrid sentient arena. It's called grounded reasoning over large corpora, which, to be honest, a more boring name could not have been written. Yet at the same time, it could not have been a more important topic. The majority of our friends working in finance, in large enterprises, are constantly talking about data aggregation as synthesis being one of those tedious problems they wish AI solved for them. And that also makes it the most economically prolific problem right now in terms of finding solutions in verticalized spaces. In AI customer service, sales, compliance, there are many, many startups that are trying to solve the problem of grounded reasoning, where that means that AI needs to follow certain rules and procedures. In AI finance, that means that it should be able to do root cause analysis or comparisons across multiple large data sources. And in AI whatever, whatever, it doesn't matter, you get the point. The problem of grounded reasoning is ubiquitous, and so the goal of the challenge is to experiment with as many tools as possible and build as many prototypes as possible to beat grounded reasoning benchmarks. And so for Challenge Zero, I would like to introduce you to the first benchmark of the hour. And can everybody give me a small drum roll? Everybody might know this benchmark. It is called Office QA by Databricks. This benchmark for the foreseeable future is what our hybrid cohort will be focusing on. For context, Office QA is a set of Q&A pairs over a dataset of parsed SEC filings. And systems like Claude Code, out of the box, are not able to pass even 25% of the hardest subset of Office QA. And to beat this and similar benchmarks, we ask that you think of solutions in the form of coding harness skills. Think of sets of skills for harnesses like OpenHands, Codex, OpenCode, or other open source coding harnesses. One thing to note is this actually gives the developers the most flexibility possible. You may take full advantage of the harness or write your custom agents as skills themselves. And if you're staying after the talks, I will ask for two things, and I will also ask for these two things of all of our online participants. I ask that you present your solution demo or at least a solution proposal. And if you're interested in exploring the deeper parts of what it means to build grounded reasoning agents, I would love to see research proposals if that is something that you're interested in. And I will speak about that more towards the end of the talks. But for now, I want to transition to our best friends from OpenHands, Dedos Labs, and Daytona, and AlphaHive, who will help you get a deeper understanding of the common tools used in grounded reasoning research, and also how to leverage AI for automated AI engineering itself. I hope that you find their talks interesting, and I hope that as you listen to them, you note down as many ideas for yourself as you can on how you may approach the grounded reasoning challenges like Office QA, or maybe grounded reasoning challenges that you face at your own startups. And with that, I'll pass the microphone to Saria from OpenHands. I'll speak to you at the end of the talks.
All right. Thank you, everyone. I'm Sharia from Open Hands, as Oleg just mentioned. I'm here to present what exactly you can do with Open Hands. Maybe we can even start by talking about what exactly Open Hands is. So I'll go through all of that. So as Oleg mentioned, a lot of what we're trying to do in this particular challenge is create this sort of grounded reasoning over large data sets that aren't exactly the stuff that's been tackled most frequently, which is like code for the most part. So the problem, is where like this main problem is that, current AI systems aren't really meant for the type of reasoning that SEC filings or other stuff have embedded in them. You probably need to go in and like kind of give agents some cues and some additional skills and whatever else. And that's the challenge that all the teams here are exploring. How you can actually do it, as Oleg mentioned, is with these skill packages. So you can put like instructions, you can put in a lot of like conditional logic and, just explain how exactly the system should work. And usually you do this by like, you attach this to an agent system. Um, we expect that a lot of you are going to have different approaches because, part of this might be a little bit of an aside, but part of the reason why coding agents have gotten so good in the past couple of months is that there's a bunch of these coders who are going through and putting their own logic into these systems through like all these different companies like Mercor that are marketing this data. So there isn't that equivalent like data set for these other corpora, right? So that's sort of what you'll have to build yourselves in here. So the benchmark can help with that. A lot of it is also just like you'll be using your own like good taste to do a lot of it. And this is where Open Hands comes in. So Open Hands is a lot of things. We have a SaaS app, we have a CLI, so you can kind of use it like Claude Code. It is a literally open GitHub repo that you can go grab and like host a version of it if you want. We also have this thing called the SDK, and the SDK is the actual thing that you will probably find is most useful. It has a bunch of skills built in, but all these skills lean much more heavily towards the coding use case because for the most part, for the past 2 years, or like, tangential history lesson here is like, we were originally called Open Devon, right? Because we came out of this challenge of like, Devon was like, we're gonna make a completely autonomous software engineer. And the folks who originally started Open Hands are like, that seems like a harder problem than you guys might have solved. So let's take a look at what it would actually take to do this. So for past 2 years, we've been building better and better skills using our own judgment and seeing like building our own benchmark to do this. But our architecture is very generalizable. You can take those coding skills if you want and use those, or you can replace it with other ones that you particularly care for. And you can build your own reasoning system. So a little bit about us. We're a fully open source project. We have a lot of GitHub stars. I always get the number wrong. I say like 40,000 or 50,000, but that was when I joined. So now we're at 65,000 GitHub stars. We have a lot of open source contributors who've been very active part of our community. Lots of enthusiastic discussions. If anybody here has been involved in open source discussions, people tend to come in with a lot of passion and feelings, and there's no shortage of that in our community. And we have lots of open source downloads, right? A lot of people have used our product and come back and tell us how we could do better. If you go to use the pure like SaaS version of the product itself, right now we have done a benchmark of a bunch of different coding models out there, and we found that Minimax 2.5, M2.5 is about as good as Claude Code for a lot of things, and we're giving it away for free on our website. But you all might want to load your own custom skills, and for all of that, you'll probably want the SDK. But just in case it's something you want, you can go for it. My goal is pretty much to tell you how exactly to use the SDK. And to do that, we made a little demo. And like, this is where, I just wanted to lay out the architecture here so that you can more easily tune it for whatever you like. For me, the really important thing is the third part here, the Open Hands agent. That agent runner, that's where the skills are taken in, and that's like the thing that's actually calling to the back end, sending off a little task, getting the result, and combining that into like a larger scope of work that gets done. The very specific thing that we do here is like we talk to GitHub with this agent, and we upload a bunch of documentation. So first, what happens is that we have this, we have a flow in our demo, which is like, we'll clone one repo, then we'll clone this other target repo where we want to put the documentation in. What our agent does is it goes through this pretty large corpus, right? Maybe thousands, maybe tens of thousands of lines of code. It goes through all of that, and then it creates documentation for that target. And then it takes that documentation, puts that into that second repo over there, and then uploads that. And so the agent kind of handles all of that. And you just sort of like, and so, the core part of this, again, is the OpenHands agent. We built this demo in like 45 minutes. So the goal is not that you should go and use this particular agent. It's to show you that you can make an agent like this very quickly and tune it and put in whatever skills you want. So what exactly does the SDK offer you? It sits right in that sweet spot where it is doing a bunch of the bringing up the agent worker, and it's calling out to the LLM. And so you need the actual key for that. So I think everyone here should have an API key for an LLM, but I'll tell you where exactly that will go. And then the agent itself is going to be running things. You don't need to worry too much about what it's doing. And then the actual whole run is called the conversation. So in this particular demo, we use 3 tools, the terminal tool, file editor tool, and task tracker tool. These are pretty generic. These are just what you need to like run something on a computer. So we predict that you'll probably need to use these as well. We then have a prompt, which is actually tells the agent, here's what you need to do with these tools. So you can pretty much take whatever we do and change it to what you want. And then it goes in, it does stuff. Now I can kind of go through this, but I'd much rather kind of show you all what exactly it is. So I'm going to switch over to the demo now. All right, so if anybody is adventurous enough, please feel free to follow along here. This is a repo that my coworker Jamie made. It's called What's Up Doc. And what you can do is you can just clone this repo. So that's what I'm going to do. That's what I'm going to do. Interesting. It does not want to go over. For some reason, the terminal is refusing to go to the other screen. That's very odd.
You can't get it over, you just screen mirror your entire display.
I'll do that. That's just in the top right.
Yeah.
Okay, cool. So let me just close this. So I've got the repo here, and I'm just gonna download it. Great. So I've got the repo, and in here is, if you go into the source here, wow, this is kind of small. I'm gonna make this a little bigger for everyone. Is that easier to read? Okay, maybe. Wow, I actually think this is nicer for me as well. I should do this more often. Okay, so we've got this thing called What's Up Doc. It's got a bunch of things in here. The important piece is this agent runner. And you can see it imports from the OpenHands SDK, does a bunch of fun stuff. So we're just gonna run, this command here. So this is a bit of a cheat because actually when I ran this task earlier, it took way more than the time I have allotted in my demo. So I'm gonna do a little bit of stage magic here. But this is the command. So what this does is it pulls the software agent SDK, which is one of the things we offer, and then it looks at this other repo and says, put all the documentation into that. And so if I hit enter now, it's going to fail. And the reason it's going to fail, is because I forgot to install stuff. So we're going to go back and we're going to install all these things here. So you get the idea. This will slowly finish its thing. At the end of it, what you do, and I'll come back to this in a bit, is like you'll run the agent and it will do a bunch of interesting stuff. So what does that look like? So let's take a look at an example of this agent actually running. So this is, again, kind of too small. So let me expand it here. So I ran this a little earlier. So you can see here the agent action, list all actions. Where'd it go? Let's go all the way up. Okay, so this is actually a kind of good point to look at. So here, it's like create a documentation summary file. Now this agent knows what to do. We sort of run through the whole corpus of all the code. It creates a documentation summary in there. And then this is what it's giving us a sample of what that documentation summary looks like. And it just spits it out. Now, this isn't the most useful thing in the world, right? It's not the easiest thing to look at. So what we're going to do is we're just going to throw that up into a little server. And so that's also included in the instructions over there, but the agent will produce this for you. And then now you can see that's hosted on my local host 3000. So all the documentation that it generated, it put a little Mintlify server around that, is running it locally. And now I can just kind of take a look. It's like, okay, here's all the features in this particular OpenHands SDK. Now, the interesting thing is that you all can actually use this to understand like how you can use OpenHands. The funny thing is that we do have our own actually published SDK documentation as well. So you can take a look at that. And I spent a little time earlier this morning going through our official published documentation and seeing how good our agent was at kind of regenerating that. And so far, I haven't found any mistakes. But if anybody does find some mistakes, I will find some small reward to give you to do it. But the agent does a pretty good job of understanding the SDK, this massive, I'm going to say 12,000 line code base, maybe more, and generating this documentation. When I timed it, it took about 12 minutes for it to do that, and about $3.50 in API usage to do it. So that's pretty much what we offer, is that you can churn through a large amount of code, turn that into documentation, and then turn it into like actually browsable, usable documentation for yourself. Cool. I think that's about it. I can demonstrate a bit more technical stuff, but this covers the spirit of the actual. I just need to go back to the presentation. Cool. So this is on the left-hand side is the QR code for the presentation itself. You can use that, get the links for whatever you want. On the right-hand side is the SDK that you can use to download our stuff. But that's about it. Thank you. All right, I'll hand it off to who's next? Okay, all yours. All right, everyone got this? If you didn't get the QR code, just let me know. Thank you.
Okay, my name is me, and I will keep it as short as Shaurya did it long. The only reason being, I'm not the creator of this repo. It's done by three of our colleagues, Noah, Salah, and Baran. Unfortunately, Salah is not here to present this, and I am presenting it out. My role in understanding why Evo skills and Evo skills matter is I am also the user of Evo skills internally at Sentient. So, not the brains behind who created it, but mostly how I use it and why I use it. Uh, Skills, the new buzzword, right? But what happens when your skills are stale or your model gets updated or your harness finds a new way or a new update where your skills are not relevant anymore? Uh, that is what has prompted this repo and this paper where the team found a way to self-improve um, the agent. Now, the agent itself can be a system prompt, it can be a skill file, and the framework will go iteratively over the files, over the benchmarks that it has, and it will try to improve it again and again and again, possibly. Um, it majorly consists of five parts. One is the base agent. This is your agent itself. Uh, Second is the proposer. So proposer will look at all the evals and benchmarks the base agent runs and then tries to propose a lot of things. Generator is the one that based on all the proposals that the proposer has created, it will generate new skills, new system prompts. Evaluator will take the generated code, creates an evaluation doc or a new variant of it in form of Git branches or work trees. And then Frontier will take this and run it across different branches, and the best one will win. Once you have the best skill from all the proposals, that gets integrated. So in principle, uh, it it is a loop that keeps on working on top of your benchmarks and your evaluations to refine your skills with the best possible outcomes. Uh, and it is as simple as running this one line of command. Uh, Also, what we have observed is it works best with Claude, but all other open source models are also good. Uh, Specifically, yes. I mean, you can still run Opus, but you will be charged a lot. And the performance that we have seen between Sonnet and Opus is not that great. Trade-off is fine. So, yeah. If you have any questions of like how you can implement this with your agent, uh, I would be able to help you out. If you have questions of like how this was made, I am not the right person. I can definitely connect you with the right team members who have made it, and they can answer the questions for how it was made. So, yes, thank you.
Hi, everyone. Sorry, just a second.
Could you help me out for a second? Like, how do I just mirror my?
You just want a straight mirror.
Yeah.
Your entire screen.
Oh, okay. Cool. Okay. Hi, everyone. Nice to meet you. I'm Stipe. I'm from Daytona. I'm here basically to introduce Daytona to you. Some of you may have used it, but for those of you who have not, this is just like a short intro into what we do and how we can help you work with AI-generated code. Daytona is basically a secure and elastic infrastructure for running AI-generated code. We've been open source since the beginning, so for the last 2.5 years. Over that time, we collected almost like 60,000 GitHub stars, so we're pretty present there, and we have a nice following, which we're grateful for. And recently, we crossed almost 2 million daily sandboxes being created with our platform, so pretty proud of that, and we hope it keeps on going. When it comes to Daytona and the challenge that we're trying to solve, it's mainly about two things. So first, as you all know, AI agents generate code constantly, and that code is untrusted, risky, and generally agents require some special kind of environment where they can, generate that code, run it, and have it be secure and not have that code and that agent impact any of your production environments. So we're trying to, provide a space which is isolated, which is fast, and which has persistence. I mean, you can run your agents and run the AI generated code on like traditional providers like hyperscalers and just generally cloud providers. But usually the speed is the main problem, and that's kind of one of our unique advantages. So when talking about speed, what makes Daytona different is that we control the whole tech stack. So all the way from the bare metal servers all the way to the clients, we own everything, and that enables us to provide the sandboxes quickly and fast. And yeah, it also allows us to provide some unique features, which I'll comment on later. So when it comes to like the features that we have, the first one, the most obvious one, which you're gonna probably use when you start with Daytona, is just like creating a sandbox. What we usually do is like a lightning fast sandbox creation. You just call the SDK or like the API to create this sandbox. We spin it up in under like 90 milliseconds, and there you have it. In that sandbox, we have a secure and isolated runtime. So all that AI generated code or the agent can just go, I would say mayhem, but like it can do whatever it wants to. There's zero risk to your infrastructure. When you're done with the sandbox or you're ready to, I don't know, shut down the agent or like pause it or anything, we have easy to use commands like pause, archive, whatever you need, or like even delete the sandbox once you're done with it. Also, massive parallelization. So if you need, I don't know, to spawn like 1,000 agents in a second, or like you want to run some kind of concurrent evals, or basically anything that requires spawning up a lot of the sandboxes, we can do that, and we do it pretty quickly. We're also stateful by design. So of course you can use Daytona sandboxes for ephemeral purposes and for like stateless use cases, but we're stateful by design. Some providers, usually last for like 5 minutes or like up to 45 minutes, but our sandboxes can run for days, weeks, even months. I wouldn't go maybe into years and stuff like that. Like some other stuff could break, but I'm sure like our engineering team has it figured out. And yeah, you can run stuff like OpenClaw for quite a while. I actually had my OpenClaw set up in a sandbox, and it ran for like a month in a sandbox. I forgot it was even there. So yeah. It's also fully customizable. Like each sandbox can be created from a snapshot. Snapshot is just like our word for creating a template for a certain sandbox. So for example, if you need to, spin up a sandbox which already has some dependencies like, I don't know, matplotlib or Python or Cloud Code already installed, you can just like create a snapshot either manually through like a configuration or through like make just a snapshot from a Docker image. And then it's easy to use and spawn these sandboxes. We're also globally available, so we have servers in NA, Europe, and Asia. Although we are trying to expand some of the servers like in Africa and maybe more clusters or like local regions in Japan and China. Our API design is agent first by design, so your agent should have a nice time, figuring out what kind of functions they have available, But it's also like made for humans. If you know try out some of our SDKs, like the Python and the TypeScript are our flagship SDKs. Go and Ruby are also good, but like they've been recently published. I think you're going to find it really nice to work with. We also have Java, Elixir, and Rust upcoming, but those are still work in progress. We also have MCPs, which your agent can use, or you yourself, and the Open API spec. So tons of ways to work with what we offer. When it comes to the features of these SDKs, we offer a few, straightforward ways to get started. First one is just like once you spin up a sandbox, you're probably going to want to execute something in it. We have easy tools like, process, execute, and then you paste the command or whatever you want to run. To get the response and like check if the sandbox is still alive or if something bad happened, there's usually like exit codes you can check for, or like the results of the response. So it's pretty easy to like execute stuff inside the sandbox. You can also do it asynchronously. This is usually like useful if you have, I don't know, some kind of environment variables that you want to use maybe in 2 functions or 2 commands. It's very easy to set it up. As you can see here, we have like command 1 and command 2. They both use the same environment variable, I think. So yeah. The file system toolbox is also a great way to work with files. You don't need to use like Bash or any kind of custom tool to interact with the file system. It just comes included with the SDK. You can see here like search files function, replace in files function, download files. So I think it really makes it easy to work with files, and it's definitely useful, since usually when you work with a sandbox, you need maybe a chart or a data set you want to upload or download. So I think this will help you out greatly. There's also a Git toolbox, so of course you can build your own configuration and have the sandbox do it custom. But we also have a Git toolbox that you can use for like cloning, push, committing, and pulling the repositories. So yeah, makes it that easy. We also have an application preview URL. So whatever you have in that sandbox, it can be easily previewed with a URL. You can go into a browser or just like CURL it in a terminal, and you'll get the output. There's a pseudo terminal in case there's any user input that is needed for a sandbox or for the process you're running. That's a pseudo terminal. And we also have sandbox volume. So if you have any huge data files or data sets that you want to use across your sandboxes, it's just easy to upload that kind of file or anything into a sandbox volume, and then it gets shared across different sandboxes. Also recently, we've been improving our computer use features. So inside of a sandbox, you can easily spin up a Windows, Linux, or Android instance, like a small computer, and you can give your agent the ability to use visually the Windows instance or the Android instance. So it can be great for like training the models or just like doing something automated with it. For example, I don't know, you can if you need the agent to use a PowerPoint desktop application, now it's easy to do so. You just spin up a sandbox and give the agent the sandbox to work in, and you can, it can click around, type in URLs, close the windows, and stuff like that. But we also it's not only agentic, we have a human in the loop. 2 basic ways to interact with the sandboxes are just like the SSH and the web terminal. They're basically the same. It's just like the web terminal might be a bit more convenient. And we also have first-class Docker support. So you can, those snapshots that we talked about, you can create them from Docker. You can put Docker inside the sandbox. There's also Docker Compose support. So there's different ways to work with our sandboxes, but all of it is really compatible with Docker and even based off of Docker. So and for use cases, like this varies a lot, and we're still seeing new use cases come up. But mainly so far, it's been the Daytona sandboxes have been used for reinforcement learning for agents. So like doing any kind of training, running just the coding agents or any kind of agents inside the sandbox, data analysis, AI evaluations, and data visualization. So there's been quite a different use cases. The best way to get started is just like to check out the docs. We have a few guides like quick starts, but also a few guides that are maybe specific to some of the use cases if you're working with RL or something else. So pretty easy to get started. And yeah, if you want to connect with us, we also have a Slack community. That's where most of our engineering team is, and they're pretty fast to respond. So if you have any like issues or you just want to learn how to work with Daytona, we're basically there 24/7, 7 days in a week. You might not get a response like immediately and within 5 minutes, but like within a few hours, we're usually there with an answer. And yeah, that's it. Thank you very much.
Okay, thank you, Steve. So next up, we're going to hear from Kathy, the co-founder of Daedalus Labs. I think she might be in the room next door.
I never figured out how to extend the screen or have speaker notes. Okay. Good.
So you want speaker notes here?
Yeah. Are you guys all local? Did anyone fly in for this? No? Okay. Okay. Okay, kind of. Kind of. Yeah. Well, thanks for being here. Yeah, our office is in Soma. Everyone's welcome to come visit and co-work. Thank you. Huge lifesaver. Oh, shoot.
Glad you use Arc browser. It's the best.
Thank you.
There you go.
Oh my gosh. Does this control that?
Should be good.
Does it really?
Yeah.
Looks like it doesn't.
It's not connecting. It's fun.
Sorry? Oh, yeah, awesome. Okay, worst case, I just...
It's weird that it's not.
Okay, worst case, I just don't.
Okay, I think it's done.
Oh, thank you.
Just go full screen on that.
Thank you so much.
Try it.
Try, cool. Hey everyone, my name is Kathy and I'm the CEO of Daedalus Labs. Let me move this, I'm a little short. Okay. So we're a YC Summer 25 company. So we've existed for like a few months. And today I'm here to tell you guys about something that we've been incubating internally within our company for a while now. And it's precisely like from this moment, like today, to a fully autonomous, like agent to agent future, what do we need from the rest of the world? So before I do that, I want to give you guys a hot take. And I feel like it's actually not that hot. I think 99% of the useful agents, tools, and services that can exist in this world does not currently exist. It doesn't exist not because foundation models are not good enough. It doesn't exist not because we don't have like the basic tools and infra to build agents. But I think it exists because we don't have the imagination. So precisely the things that I think about is like most builders who are building agents don't actually know what an agent is. In most industries that can be fundamentally transformed by agents also cannot define what an agent is. We cannot build what we cannot picture, and we cannot picture what we cannot define. So I want to start by defining what an AI agent is. So I'm pretty sure like if I asked people in this room or like people in the live stream, I think there's a live stream going, to define an AI agent, there's probably like 1,000 different answers, right? You probably can tell me an analogy like it's like OpenClaw or it's like Claude Code. Yeah, but precisely like what is an AI agent? Why isn't every single billboard in SF? And why is everyone claiming that their service is agentic? Well, we at Daedalus think that the definition of an AI agent is actually quite simple. I think that it's basically at least one model, which acts as your brain, and then at least one tool, which acts as your body, which allows the model to interact with the world, and hence that is an AI agent. Now, this is not to be conflated with other definitions of like AI agents, for example, a workflow, which is super rigid. You may or may not build this on N8N or like Zapier and you drag and drop things. I don't think that's an AI agent, right? Because it doesn't really respond to everything in this world when things get chaotic. AI agents are also not just wrappers. So if you build a GPT wrapper or Nano Banana wrapper for whatever reason, I think that's like a very basic thing. And broadly speaking, if it cannot really interact with the world, it can only talk to you, not really an AI agent. And last but not least, I know skills has been floating around for a while. Skills are basically just markdown files. Like, I think they're important ways to tell models how to use tools, but it is also not an AI agent. Now that we talked about what a single agent is, naturally people are like, okay, but like nobody really builds single agents now, right? Everyone is building multi-agent workflows. So what is the difference? I think given that this is our definition of what an AI agent is, the line between what a single agent looks like and what multiple agents looks like is kind of blurry, but also not really. Here's my take on single agents versus multiple agent setups or like sub-agent setups. I think that multi-agent starts when context and access are delegated. So I made these slides and they look really ugly, but here's the setup that I envision in my head, right? You have like a primary parent agent, which probably has overarching context of everything. Like I've talked to a lot of YC founders recently. Some people just straight up connected OpenClaw to their entire company. And when you have a powerful general agent that has context to everything, it's actually really quite nice. It connects a lot of dots. It's very powerful and also very scary. You probably don't want to give it access to everything if it knows everything, right? So you have specialized agents, however many, to complete the task at hand. And then you have agents interacting with the rest of the world. So this is how I envision things going. The primary agent probably has context, so therefore it can define goals given an intent. And it creates some kind of like sub agent, like it distributes the goals to sub agents or like other agents with smaller context, but also dynamic access to different models, different tools, different secrets, which I think is quite important. And then action is taken at a very scoped level in this world. I think this is what a very safe agent architecture should look like. And we're also very far from it. I will also make a note that if your task is super simple, maybe one agent with multiple models is enough because an agent can in fact have multiple models in it, which I think is like slightly confusing. I'll talk more about that later. So now we talked about what an agent architecture maybe could look like. I also want to talk about like some of the pretty popular protocols that are currently floating around, namely MCP and A2A. So what is the difference here? I feel like most people in this room already know, but I'm just going to quickly go over it. MCP allows models to talk with tools within an agent, but then between different agents, you need some other type of protocol. Right now, it's looking like it's A2A. It could be some other A2A, not Google's. I don't really know yet, but I do think this is a very underdeveloped space. I'll talk more about this later, but broadly speaking, MCP gives your agents the tools, and A2A allows agents to talk to each other. Given all of this setup and context that I've talked about, I want to talk about something that I have laid out for a while, and that's the 6 steps we need to get to a fully autonomous A2A future. Step 1. I think we need an A2A or agent native communication layer. Now, this is probably just MCP or like A2A or something else, right? There needs to be a native way for your model to talk to tools with full understanding of the input output schema of the tool so it doesn't hallucinate. And at the same time, there also needs to be ways for models to communicate with each other. Now, this could be as simple as just like a tool call or like a handoff, but it could also be other things, right? Depending on how dangerous the situation is, how much trust goes on, and like various other things in the world. But yeah, this is broadly speaking solved. Step 2, I think we need infrastructure that is scalable because once you build agents at scale, you don't want it to break after like 10 users use it. But most importantly, I think it also needs to be hosted and vendor agnostic. Let me explain. So first, you need to easily build and test a single agent. And when I talk about test, it isn't just like change the prompt a little bit, right? Like switch up the skills a little bit. You probably want to test it with different foundation models out there, models with different weights, models that are performing differently at different benchmarks. And then you probably also want to test it with different tools. If you're building a web search agent, for example, how do you know what is the best web search tools out there? You don't really know, so you probably want to test. And given your prompt and maybe your client situation or the benchmark that you're hill climbing, vendor agnosticism is actually quite important. Now, naturally, when you are testing with different models and tools, you probably don't want to spend a lot of time connecting different things, right? If you had to rewrite the code, like rewrite a bunch of bespoke code every single time you switch a provider, because different providers have different input and output formats, I think that's a lot of time wasted. That shouldn't be wasted. At the same time, after you build and test a single agent, you probably want to deploy it to the rest of the world so that other people can now call it. And then your other agents can also call it. And then you can have a long running, long horizon task of just like multi agents doing something for you. So, step 2, vendor agnostic, scalable infra and cloud. And I'll show you guys later, but this is what Daedalus does. Step 3. So great, agents can now talk to each other. They're scalable, they're hosted, but the biggest problem in the landscape right now isn't this, right? It's actually the fact that nobody actually trusts your agents. Like I personally would not trust an agent to like make an Amazon purchase for me. Because there are a lot of horror stories running around, right? There are tools out there that are actively stealing your bank information. There's a bunch of agents that are malicious. You can't promise that the humans who made these agents or the agents that made these agents are entirely benign. So, broadly speaking, security is a huge problem in the landscape right now. And I think we need dynamic agent native auth to conquer that. So, I know that people are like, okay, but like auth is solved, right? Like OAuth is like basically what all the big players are now adopting. And yes, OAuth is great in most cases, but it's also not sufficient for autonomous agent system. For example, I think OAuth handles most of the delegation of access pretty well. But if you're truly building out agent to agent delegation, I think that needs more than just like standard user consent flows, right? Some of the time you don't even have a human in the flow. So how do we build better like machine native non-human authorization flows? A question for everybody. I also think that when we talk about non-human authorization flows, it's dynamic, right? Like I said, you have to scope the delegation. There's varying levels of trust and context that is situational. And most importantly, like your secret just can't let loose in any way. Like you just can't be running nude around the internet. So you need better auth. That is also something that Daedalus solves. First, we built out a lot of open source frameworks, including our own open source MCP framework, but we also released something last 2 months ago now, because it's March, 2 months ago, called DAuth. DAuth is the first secure and multi-tenant MCP auth solution to exist. So it covers OAuth 2.1, but it also covers every other single case of auth out there, including API key exchange, other token exchange. And it gives you dynamic varying levels of access, which I think is really important when you're building out your entire agent architecture. More on that later. Step 4, great. Agents can talk to each other, they're scalable, they're hosted, and assuming that they're now secure, now how do agents pay each other? How do agents pay other humans? Maybe in like the case of rent a human, right? I don't know. But there's a lot of like recent protocols floating around like X402 or Google's AP2. I'm not exactly sure what's going to win just yet. I think this is like a very primitive landscape, but we're currently integrating with a lot of them. Many more exciting things to come, and I think there's a lot of potential here. That's all I'm gonna say. Not something we're building personally, not an expert, but someone should be looking into this. Step 5, and this is actually really important, right? So let's think about this. Without an app store, what would this world look like? So imagine like you're using your phone, but then there isn't really an app store. So there really isn't an environment for premium software or premium products to exist. I think that remember how I said 99% of the useful agents, tools, and services that could exist do not currently exist. They don't exist because, first of all, the incentives don't align. Most something that I should probably talk about here is like we talked about auth and we talked about how OAuth isn't a solution to everything. OAuth is also not what most people are currently implementing today. Yes, OAuth is secure. Also, the majority of tools to exist don't implement OAuth. They don't implement OAuth because it's kind of hard. You need a certain level of security expertise to implement OAuth, but also because they don't have the amount of resources and manpower that big tech or big names like Google, Notion, and Slack have in order to build this out. This is also why most of the popular tools to exist that agents can now call are mostly built by names you already recognize. But like, what about everyone else? What about the open source community? What about the early stage teams out there, the teams in YC, like mine? Or what about the one person unicorns? I'm a firm believer that the next unicorn is built by one person, and that person could be you, right? But first, you need to find a way to make money with your product. And that's why I think a monetizable marketplace for agents tools, extensions, and services is actually really important. The incentive structure align and everyone can now monetize. And most importantly, you shouldn't be the one spending the time building out the financial infrastructure. You should just publish your agent and start making money immediately, like build in public and also get paid in public. We may or may not have worked with Stripe for a few months now, and we're pretty excited to announce that we're launching the first monetizable agent extensions marketplace this month. Thank you. More on that later. We're dropping a very hype video soon to launch this, and it may or may not include a new feature that we're piloting soon. It's called Agents as a Service, aka AS. So look out for some ass on Twitter. Thank you. Last step. I'm not done yet. So let's think about this, right? Agents can now talk to each other. Agents are hosted. They can call each other. They can pay each other. They're secure. What's next? All seems great, but most importantly, if I ask you, now you know what an agent is, what does a good agent look like? You don't really know that, right? Neither do I, because we don't really have benchmarks that define success. So step 6, and this is something that's like way later, but also why you're here today in Arena, right? I think benchmarks and evals are actually super important. Only when you have a definition of success can people then hill climb, can people then race to be on top of the leaderboard, right? And the possibilities are pretty infinite. If you think about it, given that our definition of the agent is any number of models plus any number of tools, I can now ask very simple questions like, given a use case of web search, deep research, or reasoning over long corpora, like large corpora, what is the best combination of models and tools across any provider to do this? The possibilities are infinite. The possibilities to monetize are also infinite. And there's so many things that we can test and measure, right? Like cost, like latency, like success rate, like efficiency, like performance. Endless things to measure. And I am urging that more people are looking at benchmarks and evals. And it's probably also why you're here today. Let's talk about today's benchmarks, but first I drink some water. So, a lot of today's hardest benchmarks are adjacent to ground reasoning, and I'm sure Oleg already talked about this, including Browsecom, Gaia, Apex Agents, Finray, and others. However, it is still unclear, right, what a good deep research agent could look like. And this is probably why, like I said, we need better, proper, and more open source benchmarking evals that are contributed by everyone across the world. So this is why Deadlist is here. This is also why Sentient is here. We're urging more people to hill climb different benchmarks, but also be creative in your architecture, in your setup, in the way you're hosting and like dividing up context, scoping out auth, things like that. Happy to talk more after the talk about this. I think the possibilities are endless and I'm very excited. And also, if you're also excited about this, you should reach out to us and collaborate on post-training benchmarking. Cool. Now, going back to the first slide that I have, right? I said 99% of agents, tools, and services that can exist don't currently exist. I call this phenomenon the imagination chasm. But how do we cross the imagination chasm? That's a really good question, right? Broadly speaking, why are agents so bad today? We can churn out software 10 times faster. Everyone is vibe coding, and yet agents are still so bad. The software is still so bad. Most of the things still don't exist. One, because people are not starting from pain points. You're not actually making things people want. Two, because I feel like you need a certain level of product and world intuition to truly build something people want. But three, because the real world is actually really complex. It's unpredictable, it's unsafe, it's malicious, and most benchmarks out there don't currently cover all of these chaotic cases, right? Which is also, again, why we need better benchmarks. But at Daedalus, I think in order for agent to truly perform well in the real world, not only should it obviously solve a pain point that people have and it should be something people want, but also I think agents need to be nonlinear and non-deterministic. So going back to my first definition of agents, right? Agents are not workflows. Agents are not model wrappers. Agents are not skills because these things are static, they're not nonlinear, and they're not non-deterministic. If you're hard coding what your agent is doing on step 3 when something happens, then if that thing doesn't happen, step 3 will never happen. More importantly, if you're hard coding how your agent branches out, how your agent decides how to scope things, then it just doesn't work, right? Because the real world just simply doesn't work like that. Humans are nonlinear and non-deterministic, and so should agents. So at Daedalus, we think that given all of this talk, like agents seem really complex, but it's not, right? It should be super simple to build a nonlinear and non-deterministic agent. Here are the 3 steps that we think it takes, and it only takes 3 steps to build an agent. First, you define your intent, what you want the agent to do, and you provide it enough context. I think that's pretty simple. Second, you select the right models and tools for your agent or agents, like parent agent and sub agents. And then third, you set the right access and guardrails. There aren't a lot of guardrails to exist right now, but also like multi-agent orchestration is a pretty new topic. So I think there needs to be a lot more work on the third step, but this is really all it takes, right? And then you let your agent run. So nice to meet you guys again. My name is Kathy, and I'm the CEO of Daedalus Labs, and we are the simplest way to build and deploy and soon monetize your agent. So a bit more on what we offer and what you can use to hill climb benchmarks in Arena. First, we have an open source, multi-model, and vendor agnostic SDK. TLDR, you can build a production grade tool calling agent in 5 lines of code, and it's very low level, so it could be any level complexity you want. We are strictly a superset of OpenAI's agent SDK, but we don't lock you into any model. You can use Anthropic models, you can use OpenAI models, you can use Gemini, DeepSeek, Kimi, I don't care, right? You can use any models you want, and I think that's super important. You can also use any tools you want, remote or local, in 1 line of code. Zero configs, we not only connect it for you, we also deploy it for you. Second offering, we will host your MCP servers, and we gate it with authentication. So not just OAuth, but also API key access. Anything you want, we will cover it for you. Zero configs and zero Docker. I think that's pretty cool. Our framework is open source. You should check it out and start our repo. Soon, and I mentioned this briefly just now, we are piloting agents as a service, also known as AaaS. Right now, you can host MCP servers, but very soon you can serve anything. You gave us the code, we will host it for you in containers, very cheap containers, gated by DAuth, our own authentication framework, so that anyone or any other agent, OpenCloud, Cloud Code, I don't care, right, can directly call you. I think that's really important, and also an fundamental step to an A2A world where agents are calling each other. Concretely, this is slightly small, but don't worry. Look, we have a bunch of cookbook and tutorials on our website. Here's a super quick demo I built in like 30 seconds. Something that you can directly copy the code and use for Office QA. So remember how I said you need 3 steps in order to build an agent? Intent, models and tools, and then access and guardrails. Here's your intent. You provide the context, you tell your agent what you want it to do. This is usually where most people get things wrong. I would really be creative on the prompt and context engineering. And then you select the right models and the right tools. Notice how you can use more than one model in the same agent. And you can also have a parent agent who makes a tool called the different sub-agents to have as many agents as you want. This is up to you. People can get really creative here, and our users have. You select the right tools. So there's MCP servers hosted on our platform. We don't lock you in. We will always be vendor agnostic. So you can also use hosted servers elsewhere on our competitor sites. That's okay too. And we also can allow you to connect to local tools. Could be a local function, could be a local database retrieval, could be anything you want. Could be a skill. I think it's pretty cool. And then last but not least, this is gated by DAuth. So we promise that your secrets are and your client's secrets, if you're building an application, are 100% secure. Our platform or host service will never see it. Last but not least, we are giving every participant of Arena and Cohort Zero $100 free credits. I will share the link in Discord right after this talk. Pip install us today and please start repos. Thank you.
So for the last talk of the day, we're going to focus the research. So we have Recon from AlphaCog. He's going to talk about how you use AlphaCog to supercharge and supplement your research.
Cool.
Welcome, Recon.
Thanks for the intro. Okay. How do I do this? Okay, wait. No, you're all good. You're all good. Cool. So yeah, my name is Rayhan. I'm one of the co-creators of AlphaChive, and we help you stay up to date with and build on top of the latest research. So at the core of what we do is the problem that like every week or every month, there's kind of exponentially more research artifacts, papers, and code base, than the week or month or year before, right? So I'm sure we've all felt this problem to some extent, that it's kind of like impossible to stay on top of what the latest is in research. In a sense, like what defines a good researcher is like your ability to develop some intuition for like what experiments to run next, what to try next, and in a way that's never been harder than today. So I guess rather than, I'll kind of spare you the details or the ins and outs of what the AlphaChive product is today, and I instead I kind of want to talk about what exactly is a research artifact, and how is that going to change over the next 10 years. So I'll start off with the very maybe unnecessary but brief history of research, and this kind of dates all the way back to the late 1600s. The first kind of scientific journal as we know it today was the Philosophical Transactions of the Royal Society of London. So this was kind of a group of scientists it was kind of like a physical mailing list. They would exchange notes, letters, books. As at one point, Isaac Newton was the director of this group. And it was kind of a way to put your stamp on research, right? So as more and more people were doing science, there needed to be a way to kind of form together in groups and give research some weight, that this work is something that we've given our stamp of approval. Later on in the late 1800s, journals that we might recognize today, like Elsevier, Nature, were formed. At one point, kind of introducing the idea of peer review. So you'd have a group of scientists look at a work, approve it, give their stamp of approval, and go from there. Where things started to change was in the late 90s. A physics professor at Cornell started a mailing list where he would kind of share his physics preprints with his peers before they were actually published. And this mailing list grew really, really quickly. It soon became one of the first websites on the internet, and today that's arXiv. And arXiv is kind of a huge, immensely popular piece of scientific infrastructure today. When arXiv first came out, there was its fair share of criticism. A lot of folks who believed in peer review thought, it'd be too easy to publish junk science. People could signpost here, publish half-baked ideas, and then take credit for it, even though it wasn't actually fully baked. But nonetheless, as the years went on, kind of the pros of arXiv outweighed the cons, right? So last year in September, Nature came out with this DeepSeek R1 publication, and it was subject to a lot of ridicule because, as we all know, DeepSeek R1 came out in arXiv 9 months before, and 9 months in ML research time is kind of a very long time. So arXiv has very clearly served its purpose in the ML research community, and at the same time, it still has some drawbacks. As ML research has kind of grown exponentially, we kind of start to feel some of those problems, right? And this is where AlphaChive has kind of stepped in and had a role to play here. So this is a very truncated graph of this ML and AI arXiv papers each month. If you follow it to 2025, you can take my word that this exponential graph has followed this trend in the last few years. This is well before ChatGPT. But this starts to become a bit of a problem, right? Like there's a lot of research, and on arXiv you can only kind of like sort by recent. So like you kind of have two ends of the scale. On one side is sorting by recent on archive, and maybe on the other side is like going on Twitter and seeing what gets the most likes, right? So AlphaGov started as a project with myself and a couple other undergrads at some robotics labs at Stanford. It started like purely a social layer, so like a comment section on top of these archive papers. We had a lot of really cool discussions with like the authors of LoRa, Llama 3, DPO. They were like, this was like clearly an interest for a lot of ML researchers. That kind of felt this problem that there were a lot of papers coming out and it's kind of like hard to stay on top of it. But now this is where things start to get interesting. Around last year, Gemini 2 Flash comes out, and we realized like, okay, you can use AI tools to stay on top of AI research, right? So yeah, Gemini 2 Flash comes out last year, and it's the first time you can kind of fit a whole paper into the context of a model. Our team is like the #1 RAG haters, so this was the first time we really thought it made sense to like introduce AI onto the platform. And like basically in the first few weeks, this started surpassing the actual physical, real human comments people were putting on the site. A lot of people just had confusion on the paper, and this could kind of easily resolve those concerns. Right after that, deep research comes out. We introduce our own flavor of that on top of the literature here as well. So it's, you can kind of ask open-ended research questions and have it grounded in the literature. And yeah, if you can kind of follow where we're going here, you have AI that's able to do literature reviews, help you write papers. Obviously, they do coding. And so then the question is, what happens when you start to let it do like experimentation, right? So for those who saw like Karpathy's auto research project a few weeks ago, kind of for the first time in AlphaKive's history, people came to us, asking us not just to build tools, directly for humans to interface with research, but for kind of agents to have some type of context over research. Like no matter how intelligent your agent is, a fundamental tenet of research is like you need to be able to share and learn other discoveries that maybe other agents or people are making, right? So we kind of slapped together this MCP server. We were very unsatisfied with what this brought to the table. So like it served some immediate needs. If an agent needed some access to literature, this would provide it. But in our eyes, this kind of felt very unsatisfactory with what the future of research might be, right? So this kind of begs the question, which is like, what do we think the future of research is going to look like in a world where agents are maybe assisting with the automation and kind of helping, having every actual individual human be the head of their own virtual lab. So I'll show this kind of demo that we have internally on a given research project I have. So in this case, I have a research task where I'm trying to use an RLM for the task of evidence selection. So if I have like 50 papers, we have this feature where you can ask questions to the papers. And we realized that, okay, rather than like, again, using RAG or like putting all the papers through context to some expensive model, we need some quick way to filter through or do evidence selection, right? And so in this case, we're running some experiments where we have some base RLM, and I have a task, right? So obviously, as Kathy mentioned, benchmarks and evals are very important. So in this case, I've started with an eval that is queries on the actual AlphaKive site. And like I have a script that'll kind of run an RLM and produce this eval.md file, right? So it gives me a couple numbers that I'm interested in: precision, recall, F1. It's using this new diffusion model from Inception. And now in the purely manual form of research, like what is a researcher actually doing, right? Like I think a lot of researchers will agree that the highest leverage thing a researcher can do, besides just hassling with all the setup of compute, is like figuring out what runs to do next, right? So in this case, I can brainstorm like, okay, maybe I want to try a higher depth with RLMs. I want to try non-diffusion models. I want to increase the max iterations. And you kind of get this experiment tree, right? And what I think is really fascinating, what Karpathy showed with auto research, is like you can kind of let it rip here, right? So we kind of have the scale of autonomy, which is you can do this all manually, or you can like go to an experiment and basically generate analysis, run it, and create this tree. So in this case, like everything beyond this node was like generated by Claude. It could generate hypotheses, generate experiments, and I actually haven't run these last 5. But the point being, like experiments are a tree, and in a future where agents are doing research, it does feel like PDFs or collections of words and images is probably going to be unsatisfactory as like the research artifacts of the future, right? And I think it's going to look a lot more like these kind of snapshots of experiment trees where agents and humans can get some context into what was tried, what worked, what didn't work, and kind of build on top of research like this. So in our eyes, a kind of new age archive is going to be necessary. In many ways, the reason AlphaKive exists is because like the current ways of disseminating research are unsatisfactory. And we think basically there's going to be a lot that's going to change over the next few years. It might not look exactly like this. The form factor of how experimentation might look might change, but I think it's very clear that something will need to change here. And the last thing I'll mention is one of the reasons I think this is an exciting problem is like as the models approach auto research capabilities, I think with the current setup of open source research, the gap between frontier labs and open source research is only going to increase as models approach like auto research capabilities, unless open source infrastructure can build around autonomous research in a better way. So what I mean by this is like if you have agents doing research, the last thing you want them to do is like write up and upload to archive, because then this graph of like exponentially, it's going to get really bad and it's going to be impossible to stay on top of. But yeah, I think a lot of these problems are really interesting. And if you guys are interested in auto research as well, feel free to chat with me after. Yeah.
You didn't expect seeing me again here, but yet I am. So I don't have any slides to close us. I'll just kind of do a little bit of talking, if you don't mind. So first of all, thank you for all of our partners for their talks. I hope that you noted down as many ideas as possible from what they have shown you. But let's cut to the chase in terms of this hybrid challenge. There are two things that we're interested in for this weekend. For this weekend, we would love for you all to give us a solution demo or a solution proposal. And second, a miniature research question or a research proposal, something that you find the most interesting. And just to remind you of the setup, we're interested in grounded reasoning starting with the Office QA benchmark. We're interested in dealing with this benchmark, addressing the problem posed by this benchmark using open source coding harnesses like OpenHands, Codex, Aider, or Open Code. And we would love to see, likewise, how you're able to develop your solutions using, well, AI evolution and self-improvement tools. So build AI with AI, as people are now scarily saying, or as you may have read in AI 2027. We are nearing, as our friends from AlphaKive has said, maybe that pattern where AI is now doing AI research for us as well. So as you experiment for the next 3 weeks, I have a few recommendations. First, and maybe this goes for everybody, unless you want your credit card to go overboard, I recommend that you use open source models. Open source models like GLM 4.5 or K 2.5. They're quite smart, they're cheap, and they will help you enough, especially as you're iterating at the very beginning stages of your journey. Second, I would love to recommend that you use to the fullest the free models or the sponsored models that are already available through harnesses like OpenHands. Even without any other inference providers, you're able to use certain models straight just by using the harness. And third, please do not immediately ever run your solutions on the entire data set because in fact, we beg you to not do that, as the data set is large, so that will surely waste your credits or your credit card cap. So work with small subsets of questions at a time, learn, and iterate bit by bit. So what about submitting the solutions? How does submission work? How do people? Is there a leaderboard for this Office QA arena? And I'm intentionally excluding this information from this talk. I want to keep everybody's mind clear in this room and the many people watching the live stream and keep you focused this weekend on just the problem statement and all of the different tools that you may use to address it. However, you will be able to submit and see your scores starting this week, with each team allotted a certain quota if you are a participant in the cohort. If you're not a participant in the cohort and you would love to submit your solution to Office QA, we would also be open to you contacting us, and we'll run that for you, and we'd love to engage with you as well. So that is on the solution side. For the research proposal side, there are 3 general directions that I can recommend to you right away. First is AI self-improvement. There's tools like JEPA or GEPA Plus. There's Optimize Anything. There's Evolver. There's the integrated systems in things like Hermes Agent by News Research. And there's our own Evo skill that Meet has talked about a little bit before. And so one thing that we're very interested in learning about is how do they stack up, and how do they compare, and what do they do differently from each other? Is there really that much of a difference? What is the best way to design and use these tools in a way that helps you the most end to end? At the end of the day, most of these tools have been released in just the past month. This is a very, very new area. The second direction that I want to expose here for research is the area of transfer learning or generalizability. If you're able to look at a problem statement and say, this is the best solution for this problem, that is represented either as a set of skills for agent harnesses, or let's say as a custom agent built on a framework like Agno, or using Daedalus as SDK or something else, are you able to take that agent and actually translate it to work in a similar state-of-the-art manner for a completely different task? So if I give you an Office QA benchmark and I said, build something good for this purpose, are you able to then bring that solution and generalize or transfer it somehow, maybe build an agent or some kind of pipeline to then say any other person who has a very specific problem is able to adapt to the solution for their needs? Third direction is, I would say, automatic evaluation. And this kind of sounds old and tired, but think about it this way. Evaluation is hard at the end of the day. And evaluation is specific to the tasks that you're solving. And so when you look at the different self-improvement / AI evolution algorithms, the design of these evaluation metrics is going to be critical in telling AI how to, well, improve itself over time better. And so do not look at precise static benchmarks that we have now. In fact, I would say Office QA, or any other benchmark for that matter that is static, is not a true benchmark for the end product that you would build for your startup. Instead, think of using those as a reference and or taking the requirements of your users and be able to automatically generate benchmarks on the fly. We have seen some papers on this topic. We have not seen many convincing papers on this topic. And so that is the third thing that I would recommend that you think about as you're approaching this problem. Are you able to automatically generate evaluation criteria, benchmarks and evaluation criteria, given a certain a certain data set and an agent that you would like to evaluate for its grounded reasoning capabilities? So all 3 of these directions are towards one purpose, and that is automating the AI engineering process and speeding up our advances in AI and its reasoning capabilities, and hopefully enabling each person in the world to be able to build AI that is unique and specific to the purpose that they want their AI to serve, and not tied to static benchmarks. But for now, we'll stick to static benchmarks. So finally, as we kick this off, on Discord, the Arena Discord, everything is live. And so we'd like for all of you guys to get going quickly. We have an intro channel for all of the in-person and online participants to introduce yourselves, what you're interested in, maybe some proposals that you already have, both in research and solutions. There's a team formation channel for requesting teammates. So if you're already a team of 2 and would like one more person, please use that channel for that. And finally, there's a product showcase channel where I welcome all the participants to submit by the end of this weekend your research proposals and your solution proposals. And we'll actually follow up individually with each one of you and work individually with each one of you on what you're most interested in. And so, again, this addresses the Cohort Zero crowd. So, Cohort Zero, we are saying hi in the room and we're saying hi online. But if you're not in Cohort Zero, reach out to us and we would love to collaborate nonetheless. Maybe no differently at all. And with that, I'll let you all go. Find your teams. Best of luck, and let the hacking around the world begin. So I'll give you some statistics. There were more than 1,000 applicants. There are 126 members of Cohort Zero, half of which are in the Bay Area and half of which are online. And so this is also why I said we would love to follow up one-on-one with each proposal. If there were any more, we would not be able to do that. So there is food over at the lounge nearby. Please welcome yourself to a lunch, take a break. The Sentient team is going to be here for a bunch more time. So we can chat. We would love to talk and get to know each one of you. And also, if you're interested, we would love to do some interviews, see what you're working on. Cool. I think that's the end of the live stream, but we'll now go into kind of networking and lunch. There's a $45,000 prize pool, by the way. Woohoo! You go to arena.sentient.xyz and you'll see it on the right. And the research proposals do matter. So obviously the leaderboard is there, but the evaluation is holistic. That's one of the other questions that I got asked. So your performance on the leaderboard is great. So maybe let's say you got a 4th place on the leaderboard. But if you also had a great research proposal, if we worked with you, if we found something interesting together, you may be getting 1st place, even though you are 4th on the leaderboard. So hopefully that clears that up. Make sense? Any other questions while I'm here so I don't run around? Yes. Yes. So the documentation is actually available, at least in the form that it is now, without the SDK, without the submission requirements or anything like that. As I said, that is coming in the week. We want to keep the weekend open to interpretation. The tools that you will be using, though, and the general setup and the benchmark are all available on arena.sentient.xyz. But I will say it one more time. It is using coding harnesses like OpenHands, OpenCode, Goose, Aider, Codex. As long as they're open source, they're totally fine with us. And then the second part is trying to beat Office QA. It's as simple as that. Any other questions? Discord link is everywhere. So like sentient.xyz/. Yes. So verification, if you're part of Cohort Zero, you should have gotten an email in your inbox. If you didn't, then I will just give you the code. Go. Okay. Any other questions? Okay. Let's eat food. I'm also hungry.